Hello guys, welcome to another session on time, speed and distance. Today we have taken a subset of the chapter time, speed and distance, and that is circular motion. So we'll start with a couple of principles and questions on this topic and see how we can apply the same principles that are used for the normal time, speed and distance on circular motion problems as well. So let us understand two different pictures which we had studied for the usual straight line uh, distances, tracks, and so on that apply to circular motion as well. And that concept which we are trying to use here is that of relative speed, right? So while doing the problems for the linear tracks, we had understood it that if both A and B, say two people who are walking on a straight line, call it a track or a distance to be traveled, if they are on the same direction, their relative speeds will be the difference between the um, speeds, right? And if they happen to start in the opposite directions, their relative speeds will be adding up, right? Similarly, for circular motion also, if there is a circular track and A and B start in the opposite direction from a common point, their relative speed will be SA plus SB. And if they are on the same direction, right? If they are on the same direction, both A and B, their speeds will be relative to each other, so they will kind of minus out each other. So let us see this problem that we have here and see how we can start with applying the same principles here. A and B are running on a circular track of length 600 meter. Circumference of the track, speed of A is 30 meter per second and that of B is 20 meter per second. They start from the same point at the same time in the same direction. The questions are when they will meet again for the first time. So let us draw that circle. Okay, and this entire track is of length 600 meter. It is given in the question. A and B start off from the same point and in the same direction. Right? A's speed is 30 meter per second and B's speed is 20 meter per second. Right? When will they meet again for the first time? So they start from this point O. So as you can see, right, A has the speed of 30 meter per second and B has the speed of 20 meter per second. Now when they start the race, when they start running, you know that speed of A is more than B. So just after fractions of second, you can see that A will be slightly ahead of B. If you can freeze that moment, for example, if I can just explain it to you, A is here and B is here. A has gotten a very minuscule amount ahead of B because A's speed is much more. So we have frozen that moment when A has gotten little ahead of B. Now what A is seeing is A has to cover this entire distance to meet B, right? A and B are together moving in the same direction. Now A is looking at this entire distance, which is the circumference of the track to be covered, so that it can meet B, right? So relatively relative speed of A will be SA minus SB, which is 10 meter per second. So every second A gets ahead by 10 meter. To cover this entire 600 meter, A has to take 60 seconds. Hope you understand. Every second A tries to catch up with B by covering a distance of 10 meter. And where is that 10 meter coming in from? 10 meter per second is coming in from the relative speed of A and B, right? If you freeze B here, then you can tell that A is moving ahead with a speed of 10 meter per second because of the fact that both are moving in the same direction. So after 60 seconds, A catches up with B. So we can write the answer here as 60 seconds for the first question. The next question says, where will they meet for the first time? So in 60 seconds, we can easily find out what is the distance covered by A. Speed of A is 30 meter per second and the time given is 60 seconds, right? So total is 1800 meters. 1800 meters is nothing but 3 rounds of this entire circumference, right? 600 meter is the track length. So it is nothing but 3 rounds of the entire track. So A has taken 3 rounds. How about B? B, if you just multiply speed of B with the time, you will get 1200 meters, which is nothing but 2 times of the entire circular track. Or B has taken 2 rounds whereas A has taken 3 rounds, and that's when A catches up with B. So if you ask where will they meet for the first time, incidentally A, when completes three turns, it is back to point O. So it is the same point as where they had started it. So it is the uh, starting point. So it is the starting point where A and B meet again and again. First time when they meet, A has covered 3 rounds and B has covered 2 rounds. Similarly, when they meet for the second time, A has covered 3 rounds again and B has covered 2 rounds again, right? Similarly, and the time taken is 60 seconds every time. So every 60 seconds passes and they meet each other, and the starting point is the place where they meet. What is the third question? Third question is where will they meet for the second time? So incidentally, we see that every time that they meet at the starting point. Okay, let us see the next question. Next question says, if A and B start in the opposite direction, when and where will they meet for the first time? So let us see the case of opposite direction. This is the starting point. A starts like this in this direction and B starts like this. Okay, A speed is 30 and B speed is 20. So you can see that together they are trying to cover the entire circle. So where will they meet and how much, after how much time will they meet? 600 meters is the total distance that they have to cover when they are going opposite each other, and the relative speed will be there, the sum of the speeds, which is 30 plus 20. So in 1 second they cover 50 meters, right? So 600 by 50 will give you 12 seconds. So in 12 seconds, A and B meet each other. Let us see where will they be when 12 seconds has passed. A would have covered 30 meter per second multiplied by 12, which is nothing but 360 meter. And definitely B would have covered the 240 meters of distance. So let us see 20 meter per second and 12, and together they are like 600, which is the entire circumference or the track length. So if O is the point, right, P the diametrical opposite point, O P will be nothing but half of 600, which is 300. So A must have been somewhere here, right? A must have been somewhere, say this distance, 360. A would have covered 360 meter, and this distance, if I can name this point Q, OQ, OQ in the direction of um, in the clockwise direction, it would be 360 meter from okay. So they meet at a point Q, which is at a distance of 360 meter on the circle in the clockwise direction. And the next question is, how many distinct points do they meet at on the track? To understand the number of distinct points, let us try to get to a bigger diagram so that we can understand the point that I am trying to make across. So consider this to be a circle. So we started with a point O, and then we see that P was the diametrically opposite point, and they meet at a point Q, which is 60 meters from P. Okay, and this entire distance is 300 meter. This entire distance is 300 meter. Now I'll ask you to divide this 300 meter into 5 different divisions. I'll tell you why. So we name it as Q, 2, 3, 4, 5. The divisions are not very scaled one, but still assume P, Q, R, S, T. They are all 60 meters each. They are all 60 meters each. Okay, and similarly we can divide here also. 3, 4, 5. Okay, now if you clearly see that first time when A starts from this direction and B starts from this direction, they meet at a point which is 360 meter from O, right? If we consider the clockwise direction. Now at Q, both A and B are meeting for the first time. Now let us think about when they start from here and A moves in this direction and B moves in this direction, where will they meet again? So we can consider Q to be just like how it was O for the first case. So they will cover another 360 distance. A will cover another 360 distance and B will cover another 240 direction, 240 meters in the opposite direction to meet, right? So this will be 60, 60, 60, 60, 4, 5 and 6. So they will meet here. They will meet at this point. This is there. Let us name it V is their second meeting point. Okay, now from V they start again and they will again meet at a point 360 meters in the direction of where A is traveling. 1, 2, 3, 4, 5, 6, right? So they will meet here. This is the third time. This is the third meeting time. And now this is the third meeting point at S, and A moves in this direction. So we'll find out where is the fourth meeting point. 1, 2, 3, 4, 5, 6, right? X seems to be the fourth meeting point. Now from X we'll again count 6 divisions or 360 degree. I'm sorry, 360 meters. 1, 2, 3, 4, 5, 6. and O is the fifth meeting point, right? Which means there are only 5 meeting points here. And what are those meeting points? The meeting points are: first time they meet at Q, second time they meet at V, third time they meet at S, fourth time at X, and fifth time at O. And O was our starting point when they started the race in the opposite direction. So we have 5 different points, and we can easily find out the number of points by looking at the ratio of speeds. 30 is to 20 is nothing but 3 is to 2, and 3 plus 2 is 5. So directly, if we have to take one answer, we can directly take that says 5 here. So we'll write 5 as the number of distinct points where they meet. Hope you understood the logic here. If the ratio of speed would have been, say the speeds would have been 40 is to 4, in that case, the simplest terms you can write it as 10 is to 1. And if they are moving in the opposite directions, so number of meeting points will be 11. Okay. And for if they are moving in the same direction, in that case the number of meeting points will be 10 minus 1, which is 9 points. And that is what we had seen in the first question, where they were meeting at only 1 point. And where is that 1 coming in from? That 1 is coming in from the subtraction of 2 from 3, right? This is the meeting point, and 1 is nothing but the origin here for the first question. By origin I mean the origin of the race. Hope you understood the logic. Thank you guys for watching this video. Hopefully we have helped you understand something out of this circular motion session. In the upcoming sessions we are going to take some more questions on circular motion, and I hope you should be able to do some practice over there. If you like this video, please do share and subscribe the channel at onlinepsa.in, and also do visit our website where you will get scores of questions to practice from. These questions have been curtailed from various competitive examination papers, and we have tried to solve it with whatever seems to be the best method to solve them during the examination conditions. Thanks for watching again. Stay tuned.